wonder if she got it. So as I was preparing for today's class, I thought, let's look at what's left in the semester and try to get it on one piece of paper instead of being spread out all over the place. So here we go. This is what I think we're at. Today is the last day of week 11. Yes, okay. So we're only going into week 14, if y'all remember, in face-to-face. So that means that we basically have 2.5 weeks of face-to-face meetings left for us here in Commerce and in Zoomville. And then we will go to people not coming face-to-face, but we'll still be taking care of business as we go into reviews and finals. So today we're going to finish up some more proofs. We're going to talk about the assignment that I gave you, the proofs project. The last, I think, let me think about that. The last big project that you have, yes. You still have a reflection to do, but that's a small project. That's just a little tell me what you think kind of thing. And at the end of the semester, when we finish the semester-long projects, the presentations are up, you'll have to do the discussion boards and give feedback on that. But those are small things. That's not a big thing. So this is our last big project that we handed out. It's due in 2 weeks, right? 2 weeks from today, is that what I put on it?
Could be.
Yeah, I think it is 11/19. Okay, so you've got that out there. And then on Tuesday of next week and Thursday of next week, I'm not sure exactly how this will fall, so I'm not, too worried about it. We're going to do some Pythagorean theorem. We're going to do some net problems, some 3D drawings, stuff like that. And we're going to hit on some of the stuff that actually I think Samantha is the one that requested we do more problems in class where we look at the types of problems you're going to have on your state board exam that deal with geometry. So before we get to exam 2. So I'm trying to do all of that stuff next weekish. Okay, so we'll see how that works out. And then the next week, I mentioned this last time and I went ahead and decided, Samantha says, yay. I went ahead and decided to pull the trigger on this. So I am going out of town the weekend before November 17th. I am really certain I'll be back the night before, like on the 16th late, but I'm not exactly certain. And so I just decided, let's just go ahead and have a video day. I already have videos made up for you guys on surface area and stuff like that. I think volume, I don't remember what all's in there, but there's that kind of thing. Looking at 3-dimensional pictures or 3-dimensional objects and figuring out the difference between area of a flat surface and surface area of a 3-dimensional object. So I've already got some videos made on that. So we'll just throw that in. It fits really well here with this 3D stuff that we're starting to do. So we'll throw that in there. So that means that nobody is coming to class or meeting with me in Zoomville on this day. Instead, you will all watch videos. I know, it's crazy. So you get 1 day for reprieve. And then on the 19th, we come in and we do our review for exam 2. I'll try to hand out, or since we're not meeting that day, I'll put it in D2L, your review problems. Probably have a video up there for review and all that kind of stuff. So the 19th is review day. Your presentations are due on the 20th, but if you're a person that you want to have it done Tuesday and Thursday, you can get that done on the 19th and just be done with it. Remember, these are videos. You're putting them in the discussion board. That discussion board's already made. Your exam 2 is on the 23rd, which is the week of Thanksgiving. And your discussion post, we said we're going to be due on the Wednesday, right before Thanksgiving. But again, if people start posting or finish posting their presentations by the 20th, you can do that over the weekend. You don't have to wait until the day before Thanksgiving to turn those posts in, all right? To mention, oh, this is what I think about your video. And so all of that is presentation projects. So that's what's left over on your projects, basically. And then the last thing is December 1st is a Tuesday. this is my deadline for me to have your grades in D2L from the exam 2, from these presentations, from your discussion board, everything. And then there will be a quiz on the final up here. The reflections, that's the last little project you're gonna have to do. It's just writing me a response to a prompt. It's nothing big. And then, so on that day, I'm gonna put up a video, and on the Thursday, we're gonna have a Zoom meeting, okay? And again, these things are only if you're taking the optional final, right? If, well, the review is. Otherwise, you're going to look at your grades. You're going to take the quiz about whether or not you're taking the final exam, and then you're going to move on. You don't have to do this. You do need to do your reflection. So the quiz, somebody asked me about that. The quiz on the final exam basically says, I've looked at my grades in D2L. I'm either happy with them, and so I'm going to take my grade and run. I'm not taking the final exam, or I am not happy, and I'm going to try to increase my grade by taking the final exam. And so there's a couple of other questions in there, but it's basically that is what that quiz is. So it's you telling me information about how you're wrapping up your semester. Okay. It's possible there could be another quiz right in here somewhere. I don't remember if there's a quiz on Pythagorean theorem or not, but I'll look. That's it. We're done. Wrapping it up. Finalizing. Questions? Concerns? So right now, I think that what you have outstanding is wrapping up your presentation, wrapping up your write-up for your project, your presentation. Oh, the write-up, when was that due? 17th, right?
Yeah.
Semester project. Yeah, always forget something. That's in there. So I figure that the 17th, one of the reasons I decided to give you guys that as a video day, I figured that can also be your day to finish working on your project presentations and get that all wrapped up and get it turned in. Nobody's got any questions? Y'all are awesome.
Do you
ready
have
to go?
the page where it was all the problem numbers and page numbers for that first project?
For the Proust project? Yeah, I think so. Here we go. Old book, new book, triangles and quadrilaterals. I've already loaded the hints into D2L for this week's. It's under week 11. You've got that. Oh, there's one homework outstanding. I'm glad you made me put that up there. One homework outstanding. It's due on Tuesday, right? It's 7.1. We looked at that last time. You're welcome. There we go. Okie dokie then. That is the end of our semester, and it's coming at us like a freight train. It's barreling down the road. Ready or not? Here we go. So what are we doing today? We're looking at proofs. What would you like to work on out of that set that we just put up there? These things. The little proofs project that you're working on. One more proofs project. Yes. Hey there. We did a couple of triangle ones Tuesday, right? So maybe we can go to quadrilaterals a little bit. Nobody's screaming. Okay. So quadrilaterals. Let me see. Oh, I need to do that. Make it all one big thing, don't I? Okay, I can do that. And push it. I haven't done it yet. Okay, for me it's page 690. All right, quadrilaterals, we're looking at 1, 3, 4, 7, 8, 9, and 10. Okay. This is 13.4 in your book. Okay, I heard number 10, so let's work on that. The diagonals of an isosceles trapezoid are congruent. Through the diagonals of an isosceles trapezoid are congruent. Okay. Number 10. First one to yell gets their little problem worked out. I like it.
I looked at them, but I mean, number 10 is supposed to be the last one, so maybe the hardest.
So sometimes the last ones are harder. I get you. The ones at the end of the list, a lot of times they do the easy one first and then they move to harder. Okay, so first of all, let's talk about isosceles trapezoid. Trapezoid has exactly one set of parallel sides, right? And isosceles means the two not parallel lines sides are congruent, right? Or yeah, congruent. Okay, so I'm gonna do my picture here. Normally we end up with one base bigger and one base smaller. Something like that. She asked for number 10. Is that not what your book has, Maria? Is it different problems in different orders? That'll be fun. Okay. Let's name our isosceles trapezoid. I'm going to call him ABCD because I'm just that creative. Okay. And then, was it, is that your number 3?
That's number 2.
Okay. Okay, good. Kind of bad. Oh, I'm sorry. Sorry about that. No, bad internet stinks. I get it. Okay, so the diagonals of an isosceles trapezoid are congruent. So what is it that they're asking me to use as my given, and what is it that they're trying to get me to prove? So the given here is
If the non-parallel sides are congruent,
okay. Well,
maybe. Or that ABCD is a isosceles.
There we go. Okay, we're given that quadrilateral ABCD is an isosceles trapezoid. Okay, so it's a little more difficult sometimes when they don't write it like an if-then statement. So we have to kind of dig out what's what here. Okay, and so the one part that they're trying to get me to prove is diagonals are congruent, right? Okay, so I'm going to cheat just a tiny bit and I'm going to say, here's this diagonal, BC, is congruent to, here's this diagonal, AD. That's what they want me to prove. I'm just going ahead and naming them. I'm not assuming anything, I'm just naming them. All right, so let's kind of walk through this and see if we can get anything. As I look through this, I know that I'm trying to show this big side here, and I'm sorry, this big diagonal here and this big diagonal are congruent. Is there anything that we know, any properties, any definitions? We got the isosceles bit, gives me these sides are congruent. We're probably going to use that somehow.
the diagonals, didn't they bisect all the angles?
I'm sorry, say it again.
Because the diagonals bisect all the angles, so.
We don't know that they bisect the angles. In fact, I would say they do not, because like up here, I can tell this looks like a tiny angle and this looks like a bigger angle. So it doesn't really look like they're bisected to me. I do know some stuff though about the fact that it's isosceles. So since we know the definition of isosceles means that those two sides are congruent, we also know some other stuff about trapezoids. There were properties that we had. I know it's been a while since we did quadrilaterals.
Could it be the transversal coming between two parallel lines?
Okay, so these are parallel lines, and I've got the diagonal here is a transversal. So what does that give me, Demondre?
Equivalent alternate interior angles.
Okay, so I know this guy and this guy are congruent, alternate interior angles. Okay, make sure when you're doing this, and if you need to, you can extend these parallel lines out. Sometimes I think that helps people to see exactly which ones are the alternate interior. Make sure when you do that, that you're taking the angle from the transversal to the parallel side, right? Not this other guy. We can't say anything about him. Okay, but this little guy here, yes, he's congruent to this little guy here. All right, and then also what on AD?
The other way is not.
Everybody agree? All right. Now, I don't know if this little guy is congruent to this little guy yet, right? Because I don't know that yet. We'll see if that works out. But I'm getting a feeling that they're probably going to be congruent. So maybe there's something we can start looking at there. There's something else about isosceles, and it's something when we do trapezoids, everybody always tries to include this as a definition, but it is a property we know whenever we have an isosceles triangle, for instance, that the base angles are congruent, right? And we did that when we did isosceles trapezoids. Y'all remember that? That is a property. So base angles are congruent on isosceles trapezoids. Where are those base angles? Everything's a base angle, right? Okay. So she said C and D, this whole guy here, and this whole guy here. That's what I heard, right? Yeah. Okay. Sometimes math just make it so difficult. Okay, so that whole stinking thing there and this whole stinking thing here, those are congruent. What does that mean for me? Maybe I need something else, maybe I don't. If I got this huge angle and this little guy is, well, yeah, that won't work for me. I was trying to compare this guy to this guy, but I don't know that yet. So, nope, won't work for me yet. Can I pull this apart in different triangles? Because we know a lot about triangles, right? It seems like all of our proofs come back down to triangles. Let me look at the triangles that use the isosceles side and the isosceles base here. By the way, are this the only pair of base angles? No, we also have base angles up here, right? So if we need to, we can say all of A is congruent to all of B. So if we need to go there, we will, but I don't think we need it right now. So let's look at this big guy, this triangle right here. BCD. And I'm picking on him because Ashley just gave me this big angle here. We already know this side. And then on the other big triangle that kind of matches that guy, pull him out. ACD here, you can see that they're kind of overlapping, right? I have the matching this side with this big angle. Why do you say side angle side, Miss Summer?
Because they share CD.
Oh, CD is congruent to itself. Okay, so we have a side, we have an angle, and then they both share this line, this parallel base on the bottom, right? Ah, so she says side angle side. So if I have side angle side, that means that these two big triangles are congruent, and then that means that their parts that correspond are congruent, so these diagonals are indeed the same. Okay. So that's how we want to work it out. By the way, not the only way to do this, right? Just happen to see these big angles in this big side. So how are we going to do that? We need to write it up. We always start with given. Good. Quadrilateral ABCD is an isosceles trap. Given. If you don't do anything else on your proofs on exam 2, you should for sure write the statement, the original given, and give the reason you know that is because it was given. Please get at least a point on your proof, right? Okay, so then what did we say? We started with a side, right? Which one? So quietly I hear. AC is congruent to BD. These outside sides. Very nice. We know that because the definition of isosceles trapezoid and then I have angle what?
C or A.
Yeah, let's go ahead and name the thing out because we do have it kind of cut there, so it's hard to tell which angle is which, but yeah, ACD, I like it. And that's what?
Congruent to angle BDC.
Mm-hmm. It's congruent to angle BDC, I heard. And how do we know that?
Because of alternate interior angles.
We didn't actually use that one, right? We just had the little guy for the alternate interior, but that's a different proof for the same thing. We could have totally done it that way with the little, we would have used smaller triangles is what we would have done. So, but yeah, you could have. Oh, you could have actually even used it here and done angle side angle. Yeah. So if you had done this, using the same big triangles, you could have done angle side angle, and you could have used that there. Absolutely. It's just not quite the proof we're doing. It's not the definition this time. Where did we get that from? The thing we did the other day. It has something to do with base angles of isosceles trapezoids. Be under quadrilateral in your word bank. Isosceles trapezoid conjecture. Which I'm sure if you look up, it'll say base angles. If you don't feel comfortable with that, you could also say like base angle conjecture, right? You could throw that in just to make sure that that's what it says. When you have an isosceles trapezoid, the base angles are congruent. It's a conjecture. We can prove it though. And then Maria says that her third step here would be that CD is congruent to DC. And her reason is because that's the same segment. Everybody agree? Or if you want to, you can call that the identity property. Absolutely, good job. So now we have 3 pieces, a side, an angle, and a side. So what do we want to say? Here's my picture.
Triangle ACD is congruent to BCD.
Triangle ACD is congruent to triangle BCD, BDC, right?
BC.
Did you say it right? No, I said it wrong.
Maybe
Probably. Okay. We can steal this from the angle guy up here that was in the right order, right? BDC. And we know that because of Miss Summer.
Side angle, side triangle congruency.
Absolutely. Side angle, side triangle congruency. Very nice. And then that brings us almost to home. What are we trying to prove again?
BC is congruent to AD.
Okay, and those are the kind of like the hypotenuse, the diagonals here. And we do know that one because I heard CPCTC. Yep, and I see it from Maria. Very nice. CPCTC, absolutely. Corresponding parts, congruent triangles are congruent. Okay, so therefore what? Wrap it up. What did we just prove?
If a trapezoid is isosceles, then the diangles are congruent.
Yeah, they should have given it to us like that, right? That would have helped. If a trapezoid is isosceles, then the diagonals are congruent. That's what we just proved. Absolutely. If they had given it to us as an if-then statement, it would have been nicer of them, right? But they didn't. Is that okay for number 10? It's not terrible, right? It's just a matter of, I've got a lot of moving parts going on over here, right? And again, excuse me. Again, like normal, there's like 4 or 5 different ways we could prove this, guys. So it's just up to you which way you want to take that, right? So I don't care. And again, on a test, I will follow you right down your rabbit hole. So if you had gone with, because we didn't know at the beginning, right? So Demondre said, hey, what about these alternate interior angles? Absolutely, they're congruent. So if we had gone that way, then we would have gone angle side angle probably. We could have done that instead. So absolutely, it would have been okay. One of the proofs due on the 19th. Yes, it is. It's number 10 on page, well, depending on your book, either page 717 or page 693. It's 13.4 is the section. So we've done this one. Check it off your list. You don't have to reproduce the will unless you want to. Thank you, she says. Oh, thank Ashley. She asked for it. What else on this page is bugging us? I don't know. I haven't done these in a long time, so I don't know what's bugging us. Diagonals of a rectangle are congruent. That one's probably going to work similarly to the one we just did, right? It's just a rectangle instead of a track. So you can assume on that one that the angles are 90 degrees because that's part of the definition of a rectangle, right? So, well, one of the properties of a rectangle, I would say. 8, that was number 7. I think you.
For number 9, could we use the diagonals to prove the base angles or no?
Now that you have proven it, yes, you can. So Summer wants to kind of double dip a little bit, is what I hear. Number 9 says the base angles of an isosceles trapezoid are congruent. Okay, well, we just assumed that one to prove this one, right? So she wants to go the other direction. She wants to assume the diagonals to go back to the isosceles. Normally you wouldn't because it's an unproven conjecture at that point. But if we have proven something, you can, of course, use it. So, yeah. What if I didn't have that? I'd probably need to go to Mondre's route, right, with alternate interior guys. But you could still do the same thing. What it ends up, this is an interesting little piece of information. These 2 smaller outside triangles, I'm going to kind of shade them. Those end up being congruent. Can you see that they look the same, basically? So these guys end up being congruent. You can prove pretty quickly because you've got these these vertical angles in here, right? And then you've got the alternate interior angles out here. So, well, those aren't actually in my thing, so that won't help me any. So what else do I need? I need another angle. Or another side. I might have to do it, I think you might have to do it using this bigger triangle here on the top. And you would have congruency because AB is congruent to BC and they share, or AB is congruent to BA and they share that side. And then these base angles are congruent because trapezoids have two sets of base angles, right? Or if you wanted to, you could think about, look, if these guys down here are congruent, then we know that same side of a transversal inside of a trapezoid, that those guys are supplemental, okay? Because they're parallel lines, right? So this guy and this guy are supplemental. So if this guy is congruent to this guy, then this one up here has to be congruent to this one up here, right? Because we know they add up to the same thing. So then we can start parting it out like that if we need to figure out this bigger triangle. Okay, that guy's congruent side, angle side, and then pick up the little pieces basically. So they all actually, these on the outside end up being congruent, but this little triangle up here at the top and this big triangle down here at the bottom, they are not congruent. They end up being similar, yeah. So we have similarity going on. But all of these little pieces, so this part of this diagonal ends up congruent to this part of this diagonal, this little guy to this little guy. It's really pretty nice once you look at the isosceles trapezoids. Nine, 8, we talked about 7. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. That's interesting. Do you know that?
Which one is that one?
It's number 8 on the page. We don't have to do it, but let's see if we, let's think through it a little bit. Okay, 8 says if the diagonals, I haven't done a lot with parallelograms, so. Of a parallelogram, here, I'm terrible. Parallelogram, there we go, are congruent in the parallelogram. Parallelogram is a rectangle. Okay, and remember whenever we draw our parallelograms, we try to keep them really generic. So I'm going to kind of stretch this one out a little bit like that. We know this side is parallel to this side and this side is parallel to this side. Let's call him E, F, G, H. And what they're telling me here, the if statement, is this guy and this guy are congruent. So basically what they're trying to tell me is, hey, you've got a parallelogram. Sometimes when the parallelogram's like long and skinny, let me give you a different example. If he looked like this, then we have this really long diagonal here and this shorter diagonal here. Oops. Okay. So it's not true that all parallelograms have congruent diagonals. Okay. It depends on how long this is basically and the angles of the thing. So what they're saying, they're trying to tell me is in order for this to happen, this has to be standing upright. So that those diagonals look like that. They're trying to make me prove that they've got to be standing upright. Which makes these 90 degrees. So let's think about that. What do we know about just generic parallelograms? EGH and EFH are congruent. Why do you think that? Because mine look the same. Is there anything that you've got that says something about opposite angles of a parallelogram property or conjecture or postulate or?
You say both pairs of opposite angles are congruent. Are you looking for the actual name?
One of the properties, right? Either, yeah, so Demondre says it's on the back of the picture that we had for quadrilaterals, that page, but it should be in your word bank also under quadrilaterals, which is on the back of that purple page. Yeah, look on the back, quadrilaterals. Like
parallelogram, diagonal conjecture.
We're trying to prove the diagonals.
Opposite angle one is better.
Okay, opposite angles, right? That's what she's trying to tell me over here. Opposite angles are congruent, and that's a postulate, maybe conjecture. It has conjecture. Okay, so it's a conjecture. So she wants to say EGH is congruent to EFH, and we can because we have a parallelogram opposite angle conjecture. Okay. How does that help you, Miss Ashley?
Depending on how you split up your triangles, you can kind of go about the same way we did with the trapezoid.
Okay, we might be able to do some similar stuff to the trapezoids. This one's actually even nicer for me for what, like, say, what Demondre wanted to do, because there's two sets of parallel lines, right? So now I've got these opposite angles congruent. That's nice. And I've got two sets of parallel lines. So like I can look all over the place and see alternate interior angles, right? This little guy here with this little guy here. Or if I turn my page, so to speak, and look at this little guy with this little guy, absolutely. I've got lots of congruent guys going on here. So what are we trying to prove? The diagonals are congruent and the parallelogram is a rectangle. What makes a parallelogram a rectangle?
The angles.
Yeah, the difference between this parallelogram up here, who's a generic parallelogram, and this parallelogram here, who's a rectangle, is these angles, right? Okay, so somehow they're trying to say, hey, if you have these diagonals congruent, then that's going to force us to have this guy is really 90 degrees, basically, and this guy is really 90 degrees. And this one's 90, and this one's 90, okay? So it forces those things to stand up straight. So if I look at it and I think about some stuff that I already know in a parallelogram or in parallel lines, I know that this guy here and this guy here need to be supplemental, right? On both sides. So I'm just looking here. But on both sides of, well, actually, sorry. It's inside of here. No, I'm right. Inside of the parallelograms, parallel lines, yes. So we need to add in this guy being the diagonals are congruent. See if that helps me any. Let's call this guy a different guy, H, J, K, L, M. There's something else about parallelograms? Something about the opposite sides?
Opposite sides conjecture.
Which says what? What do you think? Opposite sides of a parallelogram are
Congruent.
congruent, yeah. So these guys are going to be congruent and these guys are going to be congruent. And they're telling me, they're forcing me into this guy being congruent to this guy, because that's my condition, right? Okay. The diagonals are congruent. So if I pull those, sometimes it just gets really bogged down in there. If I pull this triangle out, and pull this triangle out, what do we think about those?
If they can grow,
Triangle sign.
oh, you're sorry, the same,
Because of,
the base angle. At the top.
well, we don't, well, from up here.
No, like they share the same base of JK.
Okay, they have the same side here, so that's the same segment, so that's congruent.
And then JL's congruent to KL.
Okay, these sides are congruent because they're opposite sides of a parallelogram. And we were given these diagonals are congruent. So we've got side, side, side. Is that okay? All right, so for sure these are side, side, side. Okay. Is there a way for me to show not only the, because by the way, I would have had that same side, side, side here. Right? So how does it force me into 90 degrees? So far today, we haven't dealt with measuring anything, right? So we kind of have to get away from congruencies and start looking at measuring things. So what kind of stuff do we know about measurements in a parallelogram?
Interior angles of 360.
Okay. Of interior angles of a quad equals 360 degrees.
Consecutive angles or supplementary?
This is what's going to get us there, okay? So we know that these consecutive angles are supplementary. Which means that they add up to 180 degrees, but it doesn't force them to be 90 degrees, right? Okay. We also know these opposite guys are congruent. Okay. So let me start, if I do this guy and this guy, they add up to 180 degrees. Let me write it here. Measure of angle MKJ plus the measure of angle LMK. Sorry, I'm like, which ones was I doing? That one plus this one equals 180 degrees. The trick to the parallelogram is to spin your paper around. It's not just those two that are consecutive sides on these parallel sides, right? It's also these two. Is that okay? All right, so that means measure of angle MKJ plus the measure of angle KJL is 180 degrees. Okay. We can stick that together, right? Do some kind of substitution. Their transitive property. Okay, because they're both equal to 180 degrees in the middle. Pop that out. What can I do with that? MKJ plus LMK is equal to MKJ plus KJL. I got the same thing on both sides of the equation. Can I subtract it? Yeah, I can just subtract that guy off. So LMK is angle KJL, okay? So that's these opposite guys. But if I do the same thing again and just shift over one position, I can do this guy plus this guy equals 180 degrees. This guy plus this guy equals 180 degrees. What do you think I'm going to get then?
All the angles are the same.
All the angles end up being the same. Does that make sense? If I just keep on with that process going around the quadrilateral, basically. So I'm going to end up, this guy's that guy, this guy's that guy, this guy's that guy. They're all the same. I don't have to do all four summations. I just have to do two, basically, to prove that if three of the angles all equal the same, they must be 90 degrees, right? Yay, fun stuff. I'm not going to write that proof up. I'll let you guys write that proof up. But that's one approach. It's not the only approach, but the fact that they're trying to make me be a rectangle means I have to go to measurements. Does that make sense? Because that's what makes something a rectangle. It's an angle. Okay. How you guys doing? Zoom feels awful quiet today. You have other questions, or you just need time to work on these secant proofs? Everybody out there's asleep? I don't think people in commerce is asleep. I'd have to go crap on their desk. Need time. I'm here. Yes. Okay, great. We're awake in Zoomville. I like to hear that. Okay. So Samantha says she just needs time to work on some of them. And I totally understand that, because with proofs, you just have to dig into them and start doing them and see what you can. I tried to give you those hints. Make sure you go and use them if you're stuck. They're in the document section, week 11. They might even be on the proof section under content. There's that little section of proofs information, but there are hints. So I'm not saying that the hints will help you. They help me to see the way that I want to go. But if you're trying to take your proof in a totally different direction, the hints might not help you at all. But if you're like, I have no idea where to go at all, maybe the hints will give you a start. Okay, anything else? We're really super early. This is all I'm doing today is proof, proof, proof. It's a little warm in Commerce today. Is it warm in here? So warm. It makes me sleepy when I get too warm.
That's one of the other buildings too.
What that's about. Okay, well, I'm not going to drag it out if y'all don't have anything. Hang on a second for me to call roll. If somebody screams in the next 2 minutes or so, we'll work another problem maybe. All right. I see Samantha and Maria. If you don't have any questions and you don't want to hang around, then you can have a lovely weekend, and I will talk to you later. Make sure you're ready for everything that's coming up. Work on your projects. Christina, I see you. Alexis, I see you. Have a great weekend, Maria. Jessica, I got you. Summer, I have you. I don't see Gabriel, I don't see Matthew, I don't see Caroline, Demondre, I've got you. Elijah, I've got you. I don't see Kimberly. I am probably gonna do a participation quiz soon on D2L, just to make sure everybody's watching videos and participating and all kinds of stuff. Ashley, I got you. Mary, I got you. Ryan, I see you. I don't see Garrett. I don't see Cameron. Cool the ham sandwich signing off. Take care, Elijah. It's always good for a chuckle. Thank you. Have a good weekend too, Ryan. I'm gonna stop the recording. Have fun, everybody watching the video.
I had to shoot. You can go first. I'm trying to